Hi guys, back again with another video on advanced chemical reactions. I got to thinking that maybe you might want a little bit more practice on the acid and base thing that we were doing before. So this is a little bit more just in the way of practice problems. We'll just kind of do one of each kind on this video, and then I'll move on to the next topic. So here is the first kind of problem you may see. What is the pH of an acid with a, having trouble writing, H3O plus concentration of 2.7 times 10 to the negative 4. Okay, so first thing, there's two things you really have to decide. One, is this an acid or a base? So it tells me pretty clearly it's an acid. That makes my life easier. Second thing is, am I looking for pH or pOH? And I'm looking for pH. So what I'm going to do with this problem is just the pH formula. pH is equal to the negative log of the hydronium ion concentration. And then, since it's given me the hydronium ion concentration, it's just a matter of plugging it in. So pH is the negative log of 2.7 times 10 to the negative 4th. Then I go to my handy-dandy calculator, and when I plug this in my calculator, I get a pH of 3.57. I can also double-check my work because I know acids must have a pH less than 7, so that makes sense. So there's one kind of problem that you may have. The only variation you might see in this problem is what if, I'm going to come back up here to the question, what if instead of pH, what if they asked you for the pOH? If they asked you for the pOH, you would do exactly the same thing as we've done here, except you would have one additional step. The pOH plus the pH must equal 14. So if my pH is 3.57, then I've kind of got a little simple bit of math going on here. And then I know that my pOH, I get my handy-dandy calculator here, 14 minus 3.57 is equal to 10.43. So one way you may see this problem, having trouble dragging, is if I'm given, I know it's an acid, and I'm given that hydronium ion concentration. Second type of problem that you may see is, what is the pH of an acid, of an acid with a 0.017 molarity. Okay, and it's not just an acid. Let me fix that. We'll say what's the pH of, we'll go back to our H2SO4, our sulfuric acid. So this time, again, it's asking me for a pH. So, fairly certain if I'm given an acid, which I knew I was because it starts with an H, I don't see an OH, I know I can use my pH is equal to the negative log of hydronium. I can use that formula. Problem is that that hydronium is not given to me yet. I have to figure it out. So again, if I'm given molarity, your first step is to figure out how does my acid dissociate. So my H2SO4 breaks down into an aqueous solution of hydrogen. Remember, that's the same thing as H3O plus, and sulfate. And I know that just by looking at what my pieces are over here. But I know it has to be two of these because when I'm looking at this breaking down, there's two of those for every one of those. Then my second step that I have to do is a quick little mole conversion. If I have 0.017 moles of my H2SO4, and I know for every mole of H2SO4, I get 2 moles of hydrogen, then that tells me that I have a concentration of hydronium that is 0.017 times 2, so that gives me a 0.034. That is my hydronium concentration. Again, you got to remember this H3O plus and this H plus are the same thing. Okay, sorry, I made that look confusing. Let me get rid of that 2 for you. There we go. Okay, so now I can go back and use my pH formula. So I'll say pH is equal to the negative log of my hydronium concentration, which we just found was 0.034. And when I plug that in my calculator, I get 1.47. Again, logic tells me it's an acid, that's a pH below 7, it makes sense. Again, if the question had said, what's the pOH, I would have done the exact same thing, except then would have said pH plus pOH equals 14. 14 minus 1.47 is 12.53 would be my pOH. So those are the two kinds of problems you'll have with acids. The only other difference here, or the only other option, is you may have a problem that asks about bases. So it could say, what is the, we'll do pH again, pH of a base with an OH concentration of, making up numbers here, 3.1 times 10 to the negative, let's go 4. Okay, again, I'm making up numbers here. So when we look at how this works, again, I'm asking for pH, but it's giving me OH, so I can't do this in one step. So anytime I have this, I can find the pOH. So the pOH is the negative log of the base's concentration. So plug and chug time, negative log of my 3.1 times 10 to the negative 4th. And when I put that in my calculator, I get 3.51. That's my pOH. But the question wanted to know, what's my pH? So I go back to the idea of pH plus pOH equals 14. So then I know my pH has got to be 14 minus 3.51. Oops, made a calculator mistake there. 14 minus 3.51. So that gives me a pH of 10.49. I do my little logic check. That's a base. That's over 7. That makes sense. Okay? The other way, and this is probably the hardest version you'll see, is what is the pH of NaOH with a 0.087 molarity. Okay, and again, I'm picking random numbers today just to try to make life easier. So with this question, it's a little more difficult because I have to find pH, but I'm starting with a base, and I'm starting with molarity. So this is when I have the most steps. So step 1, okay, if I'm given a base, pOH is really all I can find first. Okay, if you have a base, start with your pOH. If you have an acid, start with your pH. So I'm going to start with my base, and I'm going to find out how does it dissociate. So if I look at NaOH, I know since it's a base, one of the parts has to be OH, so the other part has to be Na. And number-wise, everything works out. So this is a 1-to-1 ratio. So I don't even have to set this up, but I will to show you. If I have 0.087 moles, I made it a little small there, of NaOH, and I have my mole ratio, it's a 1-to-1 ratio. For every one of these guys, I'm getting one of those guys. So that's pretty easy. That gives me the exact same number here for my OH. So that's my OH concentration. So then I can, I'm having trouble with those vertical lines again. There we go. Then I can go to my next step. Let me erase these so they don't confuse you. Then I can go to my next step. My next step is to find the pOH by taking the negative log of the OH concentration, which is what I just found. So take the negative log of 0.087 and I plug it in my calculator and I end up with 1.06. That's my pOH. But the original question asked for pH. So now I gotta once again think pH plus pOH equals 14. So I do 14 minus 1.06 and I get 12.94 as my pH. It's logical. It's a base. it's greater than 7. Hope those sample problem helped you guys. Getting ready for the next one.